Aloha class BC, it is Judgment Week. And with it being Judgment Week, what that means is Homie Holmes says that these are the most important problems we are going to be doing. Why? Some, I guess, AP guru out there every year does a great job of predicting what the AP exam is going to look like. So this year, right, we're all up in the air this year. So this is what he has predicted. He's come up with 5 problems for what we could see on the BC exam. So what your job to do this week is to type out this problem. Directions will be on Google Classroom. Print it out, write down your answers, take a picture of it, and submit it to me. After you're done doing that, then watch this video and let's see how you did. All right, so that's the goals. That's what we want to do this week. About 22.5 minutes to print it out, write out the answers, take a picture, and submit it to me. And so that's the goal this week. That's what I want you guys to do, just to get used to the process, okay? And so you're going to hit pause. You're going to do this stuff, and then let's see how you did. All right, I'm going to get rid of my camera and attack this guy full force. So let's go. All right. A tightrope walker climbs a pole and walks along a tightrope that extends in a straight line in both directions. Okay, from 0 to 16, the velocity is modeled by the piecewise function that is made up of some quarter circles and 4 straight lines. A says, at what time in the interval has the tight rope walker stopped? Well, we all know that in terms of looking at our graph, that if we're dealing with a particle, or in this case, a walker, it would have stopped whenever the velocity is 0. So for this particular one, and it says to label it C1A, right? For this particular walker, the velocity is equal to 0 at t equals 0, 4, and 11. Okay, and you probably would have got 1 point, it looks like, if you were able to figure that out. Okay, let's go ahead and go to B. All right, it says, at what time from 0 to 16 is the tight walker furthest from the pole? How far is he from the pole at that time? Now, it's important to notice on this one, there was not an initial condition, right? Sometimes when we're doing these problems, there's an initial condition, and if we're dealing with a particle at time t equals 0, it could have been 5 units from the pole. So I think that's important to note here. Usually we do have an initial condition like that, okay? This particular situation, we do not. So all I'm concerned with here is when the tight walker stops, right? Because he goes forward, then he might come back a little bit, and then forward again, right, to catch his balance. So the first time he stops is at time t equals 4. So what we should figure out is how far is this dude at 4, right? That would be from 0 to 4 of v of t dt. And if you look here, hopefully you did this, you notice that there is a rectangle there. And the rectangle has an area of 8. And then I'm going to subtract out. I actually have 2 quarter circles, which is a semicircle, which is 1/2 of pi. Radius is r squared. So hopefully you did that. So you get 8 minus 2 pi. Okay, and I'm going to do the absolute value of that, which would actually be 8 minus 2 pi, because 2 pi would be about 6, right? So that's how far away the tight walker is back from the pole. But then he gets a little scared, and I guess he goes backwards because our velocity is now negative, right? So now I need to find out, where is this dude at 11? Well, and able to do that, we already know what it is from 0 to 4. Whoops, 8 minus 2 pi. So I'm going to add to that what happens from 4 to 11, right? V of t dt. And that's going to be negative because it's below. So it'd be 8 minus 2 pi plus, let's add all of this stuff together. And that is a trapezoid. The trapezoid has a height of 3. And the bases are, what is that? 1, 2, 3, 4. And the other base is 1, 2, 3, 4, 5, 6, 7. Okay, so that what does that give me? That gives me 8 minus 2 pi plus, that'd be, what is that? Ooh, what did we say? 7. That'd be 11 33 halves. 33 halves, right? But it's going to be negative because it's below, so let's put the little negative sign there. And 8 is 2 over 16. So if that's, 16 over 2, so that'd be negative 17 over 2 minus 2 pi. Take the absolute value of that because that's how far we are from the pole, even though we might be going in the other direction. And that is what we would get. Does that kind of make sense? So that'd be 8.5 plus 2 pi. Okay, that's how far away we would be from the pole. Now I have one other situation that I'm concerned with. Let's see if I can fit it up here. And that would be, where am I at the very end, right? Because then you're dealing with all of that right there. And that would be what? X of 16. And so if you've noticed here, we're dealing with some things. We got 8 minus 2 pi, and then we have minus a 33 over 2 because we're going backwards. But now I'm going to add to it this positive area. And if I did this, I would probably do that, which is 12, right? That's 4 by 3. And then that is a 1 by 3 triangle. So that would be 12 plus 3 halves. Okay, and if I added all that together, that 3 and that right there, let's see what we're dealing with here. Let's see, that would be, these guys would give me a negative 30 over 2, which would be negative 15. So you have 8 and a 12, which gives you 20. 20 minus 15 is 5, so it'd be 5 minus 2 pi. That actually would be negative, so I'll take the absolute value of that. Okay, because that actually would be negative, right? And I just want to know how far we are. So that's why we're taking the absolute value of all of these guys, correct? And I would say by far, my answer would be this. So we would say we are the furthest away at time t equals 11. Okay, and I have here that probably would have got you 3 points for this particular problem. Okay, bring your questions to Google Meets. I'd love to see more of you there. Here we go. Remember, Judgment Week. Where do you stand? C, find the average velocity of the tightrope walker over the 16-minute time frame. Average velocity. Okay. That's just the integral of velocity over the interval of, and it's from 0 to 16. And we already did the 0 to 16, right? I mean, we just did that in the problem that we did before. We got 5 minus 2 pi when we did all that, and we divide by 16. Booyah, problem done. And it would be in yards per minuto, right? Yards per minuto, because that's what velocity is measured in, okay? All right, not bad. I'd probably say 2 points for that bad boy. Okay, so hopefully you're rolling. D, part D, it says express total distance as a mathematical expression and find that value. Well, hopefully we all can remember and recall that total distance is simply from 0 to 16, but the absolute value of v of t dt, right? Do we remember that, class? Okay, so then all I have to do from that is use all of those areas, but right, I'm going to make them all positive, right? I'm going to make them all positive. So the first one would be 8 minus 2 pi. If you remember, that was positive for that case here. We had all of that stuff there. I'm trying to remember what it, wasn't it like negative 33 over 2, but this time I'm going to add my 33 over 2, okay? If I remember that correctly. And then this right here was, we had a 12 and then we had a 3 halves. So these guys, we could bring 36 over 2, which is 18. So I get 38 minus 2 pi's. Okay, and that would be yards, right? Because that would be our distance. Okay, I didn't think that was too bad either. Probably get a couple points for that bad boy. And then our last but not least would be E. Write an expression, and this is kind of the BC part of this question here, okay? Write an expression for the tight walker's velocity and distance from the pole for a value of k between 4 and 5. So between 4 and 5, okay, that's linear. That's not too bad, and I just have to write an equation for velocity. Well, that's not too bad because there's 2 points on that, right? We have 4 comma 0 on that bad boy. And, I know the slope. The slope is down 3 over 2. So that's just y minus y1 equals my slope times x minus x1. And then let's just make it look fancy like velocity. So let's just go v of t equals negative 3 over 2x plus 6. Ooh, t. Right? That's it. And then it says to also, let's do an expression for the distance from the pole, which would just be x of k, right, is equal to, well, we know dealing with this piece right here, that's just 8 minus 2 pi. And then I'm going to add to that the displacement from 4 to k of negative 3 over 2t plus 6 dt. So I don't know about you, that was different. That was definitely a BC type question. I don't think my AB students would see that, but not too crazy, right? That's not too bad. And then that's it. And so what I'm going to do is get my pretty face back in here with Homer Holmes. And I'm going to give you the screen here that has all of the grading for this one, okay? And if you look very carefully, there you go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I think what he did was when he was creating these problems, what he did was he made all of them out of 10. So remember, if you're getting more than half, you're doing a great job. It's Judgment Week. It's going to tell you where you need to be. If you did not get, I would think this should be a 7 or an 8 for us out there in BC. If you didn't get a 7 or 8, make sure you come to Google Meet so we practice some more of this stuff and we get better, because I want you guys to dominate. Aloha. We're going to do the same thing with number 2, Niban.